Hello, grade 11 physics. Let me first apologize to you by saying I am sorry that I could not be there in class today or yesterday. There is just a bunch of things going on right now that we're trying to take care of, and it's very stressful, not only for your teacher but for his family as well, so we're just trying to get through that. I will be in class on Wednesday though, so you can count on me then. But in the meantime, you guys have some work that you are working on. But before that, let me draw your attention to the screen over here. So today is physics class without Mr. Russell, part 2. I'm hoping that you guys did a lot of work yesterday. No, today. I'm filming this today. No, you're yesterday. So it's today for you guys, but no, wait. Oh, you know what? Doesn't even matter. I'm doing this at night. You guys are seeing this in the morning. Today, we're doing this today, like right now, as you're watching this, we are doing something just slightly different. All right, here we go. So, you're gonna watch this video that I have prepared for today. It's a squirrel maze video. I'm sure some of you have seen this video. This video has a lot of working components of physics, and what I want you to do is, on a blank sheet of paper, I want you to write down as many physics fundamentals that you can find in the video. That's things like acceleration, torque, inertia, force, and even work, because guess what? Today we're going to be doing work. Now, if you're a teacher that's in the room, if they'll pause this video, and I sent them a link of this video that they will now play on the screen. Alright, today we're going to be doing part 2 of the lab that you guys are working on. So you're given a handout, and I wanted you to construct a ramp, similar to the one in the picture seen here. So you're going to nestle a piece of cardboard next to the wall and probably tape it against the wall so that it sticks like this. You can choose whatever angle you wish, unless it specifies in the lab. If it specifies, you will have to guess what angle, and basically rest it like that. And then you're going to put an object on the top of the ramp. Any object will do. Just make sure that you record the mass of the object in your lab. And you're going to set it at the top. Now, when you're at the top of a ramp, this represents a type of energy. This is gravitational potential energy. And gravitational potential energy is all based on height. So your mass times gravity, which is G, times your height is the gravitational potential energy. That is E equals mgh, right at the top. Full gravitational potential. It's not moving until you release it. Now, when you release it, it's going to slide down. There is friction. Do not forget about friction. You will have friction on this ramp, and it's just assuming going down a a parallel to the board against your acceleration. So your force is going this way, and friction is going this way. Now when you get to the bottom, just right at the bottom before it hits the floor, this represents a different type of energy. So you learned yesterday that energy conservation means that you can have an energy transfer, but you can't destroy energy. So while there will be some energy dissipated to the floor, this right here represents kinetic energy, 100%. So kinetic energy is energy in motion, and that is represented by 1/2 your mass times your velocity squared. And you can calculate your velocity by first measuring the displacement of your ramp and timing how long it takes the object to get from point A to point B, and that's how you calculate your velocity. So you should be able to do all the components of this lab today and finish it so that tomorrow you hand it in to me, and it will be due tomorrow. Now, if you have any questions, then you can always shoot me a message on Google Chat. I may or may not be available depending on what's going on. So you can always try that first, and I'll get back to you as soon as I can. Now, there is one other thing that today I want to show you. So there's this other thing called work. If you look at the screen, work is a type of force. And that might sound kind of confusing because there's no F in the equation, at least in this part of the equation. What work is, it's a force that's applied through a displacement or a distance. And it's really just a quantity of the amount of energy that you've used to move an object from one point to the other. So we can say that work is then equal to the change in energy, because you're changing from, in this case, from gravitational potential to kinetic. And a change in energy is going to be the energy final minus the energy initial, because that's typically how delta values work. It's a final value minus the initial value. So if you calculate your kinetic energy and you subtract your gravitational potential energy, that will give you work, like that. Now you can also represent it like this, where F is force, and remember from kinematics, force is equal to mass times acceleration, and D here is displacement, and cosine theta, that's super easy because you have the angle of your ramp at whatever you set it at the beginning. So you've got your angle, you've got the displacement of the ramp, and you can calculate work using your energy final minus energy initial. So you should be able to get a value for F right there if it asks for it. So again, work is a force over a distance. Typically when we talk about force, we talk about an impact event, something like me punching the board, but that stops right when I hit the board. But work is actually when you're moving something through a distance. So if I punch the board, I haven't moved anything. The board stays the same, so I've done no work. And that makes sense. If I punch a board, nothing happens. I maybe get some broken fingers, broken knuckles, but that's about it. There's no work done. Now, if I take the board and I move it somewhere else, then yes, I've done work because it's moved across a distance. So that is work, and I'm hoping you guys can complete this lab now with all of that information. Again, if there's any questions, let me know, and I'll see you tomorrow.